So far what we've been doing up to this point is we've been calculating what are called theoretical amounts. Theoretical amounts. And if you're talking about products, you call it theoretical yield. And this is what we're doing. This is the actual amount, excuse me, the amount, not the actual, sorry, the amount of material or product that should be produced based on reaction stoichiometry. So let's say we're doing let's just take our reaction. I'm going to take some methanol and I'm going to react that with 3 moles of oxygen, and I'm going to get 2 moles of carbon dioxide, and I'm going to get 4 moles of water. And let's say I take 90 grams of methanol and I completely combust it. And I actually collect the carbon dioxide and I weigh it out. And I find that I get, we'll say 110 grams of it. Okay? That's what I get. So the actual amount that I collect, the actual yield of carbon dioxide is 110 grams. That's what I actually collect. Let's see what the theoretical yield is. Let's see what I would expect to get if everything was working perfectly and I was able to capture all of the carbon dioxide. And we'll see how that, it should make sense. It doesn't always match with what you get experimentally because we make mistakes or or whatever's going on. So let's see here. We did this before, but I've got 90 grams of methanol. It turns out there are 32 grams of methanol in a mole of methanol. And then according to this, 2 moles of methanol should produce 2 moles of CO2. And then there's 44 grams in a mole of carbon dioxide. So 1 mole of CO2 is 44 grams of CO2. So what I'm doing here is I'm calculating the amount of carbon dioxide that should theoretically be produced if I completely burn 90 grams of this stuff. Let's see. 90 divided by 32 times 2 divided by 2 times 44, 124. I rounded up. So this would be what we would call the theoretical yield. It's what we've already been doing. The theoretical yield of carbon dioxide is what we would expect to get if we burned all of the methanol and collected all of the carbon dioxide that was produced. Doesn't always match what we actually get. So what we actually measure is called the actual yield. In this case, it doesn't fit. Let me write down the definition of the actual yield. Actual yield, it's pretty easy. Amount of product that you actually collect. So in this case, we would say if we burn 90 grams of methanol, completely combust it, in theory, we should be able to collect 124 grams of carbon dioxide. That would be the theoretical yield. And what we actually collect, the actual yield, you have to measure experimentally. You have to actually go out and do it. In that case, it's 110 grams. And what's often reported in chemistry is what we call the percent yield. How much of what you actually, I'm going to be careful here, how much of what you should collect in theory do you actually collect? This is known as the percent yield. So I'm going to write that down, and we'll calculate it in this case. The percent yield is going to be the actual yield divided by the theoretical yield. And we list it in a percent, so we'll just multiply this by 100%. So in this case, pretty straightforward. I've collected 110 grams of carbon dioxide. That's what I actually collected. I'm going to divide that by the 124 grams that I should collect in theory if everything's working correctly. And we'll multiply that, of course, by 100%. And 110 divided by 124. Looks like we caught 88.7%. So our percent yield in this particular experiment would have been 88.7%.